All right, in the previous video, we introduced time value of money. We answered a pretty interesting question where your parents invested $5,000 into your retirement account on the day you were born, and we saw how much that account would be worth when you retired at age 65. And we also developed the idea to come up with this formula, which states that the future value of any lump sum amount is equal to the present value times 1 plus the rate of return R raised to the power of t, where t represents the number of compounding periods. In this particular problem that we worked in the previous video, t was 65 and R was 0.125 or 12.5%, the rate of return on an index fund that tracks the S&P 500. What we're going to do in this particular video is we're going to rearrange or transform this equation to solve for present value, to solve for R, or to solve for T. Okay, and then I'm going to introduce how to use Excel and other and a financial calculator to calculate these time value money problems. So I think this will be somewhat useful. Okay, first of all, what I'm going to do is I'm going to say transform this equation that we came up with in the previous video. I'm going to transform this equation solving for present value. And if you see what I'm going to do here, all I'm going to do is I'm going to divide both sides by 1 plus R raised to the power of t, such that the present value is going to equal the following. It's going to be equal to the future value divided by 1 plus R raised to the power of t. Hopefully you can follow that algebra. Pretty straightforward. Okay. So in the previous video, we talked about times where we might want to take some future value amount and discount it back to today's dollars to see what that future value amount is worth in today's dollars. So we're going to solve for the present value. Okay. Now what I'm going to do is I'm going to take this first equation again, and I'm going to solve for R. This gets a little messy here. I'm going to divide both sides by the present value. And then to get t down here, what I'm going to have to do is I'm going to have to take I'm going to have to raise both sides of this equation by 1 over t. Okay. In other words, to solve for R, I'm going to get the following. I'm going to get, first of all, let me go up here, introduce this equation. I'm going to get 1 plus R. Hold on. 1 plus R raised to the power of t is going to be equal to future value divided by present value. You should be able to follow that algebra there. Okay. Now what I'm going to do is I'm going to get the t off of both sides. The way that I do that is I raise the left-hand side to 1 over t and the right-hand side to 1 over t. So now I have 1 plus R is equal to future value over present value, and I've got to raise this whole part of the equation. I've got to raise this to the power of 1 over t. Which, using this equation, this equation tool is not very useful. Okay. So then, all I've got to do is I'm going to go back and edit this. All I've got to do is subtract 1 from both sides to get R by itself here. So R then is equal to the future value over the present value raised to 1 over t, and then I just have to subtract 1. Okay. So this is the formula to find some rate of return. Think of a problem where you might want to find some rate of return. Suppose you have $5,000 to invest, and instead of getting $10 million, you wanted $20 million by the time that you retired at the age of 65. So your future value is going to be 20 million. T is still going to be 65, but then you could solve for R to see what rate of return you would need in order to reach your savings goal. Okay. The last thing that I'm going to do here is I'm going to solve for T. Sometimes it might be important to solve for how many compounding periods we might need to reach some savings goal. Okay. To do that, this is going to get messy. I'm going to divide again both sides by the present value. To get T out of the exponent, I'm going to take the natural log of both sides. So I'm going to have the natural log of the future value over the present value equals the natural log of 1 plus R times T. And then I can simply divide the natural log of the future value of the present value by the natural log of 1 plus R. So I just talked through that algebra. I won't show you how to do that. I don't know that it's necessary to understand. But the formula to find T is going to be equal to the natural log of the future value over the present value divided by the natural log of 1 plus R. Okay, and that's how you get you solve for T alone on the left hand side. All right, so you can see that initially this first formula didn't seem to be that troubling. The second formula didn't seem to be that troubling. However, the third and the fourth formula, we begin to run into, it gets a little bit messy. Okay, so what I want to do is I wanted to introduce two tools here to calculate the time value of money, and we'll refer back to this initial problem that we started to solve. The first tool that I want to use is Excel. Okay, so we solved the problem, the $5,000 investment on the day you were born, to see how much it's worth by the time you turn 65, assuming that you get 12.5%. So we showed how to do this in Excel the long way. It's actually super easy because Excel allows you to calculate the future value in a pretty easy fashion here. What I do is I say equals future value. Okay, so Excel has a formula here. And then it also has some help here. It asks me for my rate of return, and this is going to be in decimals. It asks me for my number of periods. That's going to be T in our equation, or the number of compounding periods. This payment function we're going to revisit here in a little while in a subsequent video, but this payment function is asking, are there any reoccurring payments? In other words, were your parents making a $5,000 investment every year? And the answer is no. So payment in this particular problem is going to be 0. And then I need to put in present value. Okay. So to do this, I just simply put in a rate of return of 12.5% or 0.125 in decimals. I separate everything by columns. So I'm going to say 65 years column. My payment is 0. And now let me help you understand something that's important. When you're solving for these problems, Excel is not actually using these particular formulas. What Excel is doing is it's doing some fixed point arithmetic, and it basically uses some solver mechanism to find out what the future value is. And it requires you to put in either your present value or your future value as a negative number. Okay? So the easiest way for me to think about this is I select either my present value or future value as negative if that is an outflow. Because this $5,000 is coming out of the pocket of your parents, it's considered an outflow, and therefore it's going to be a negative 5,000. Okay, and of course the future value is going to be generated up. It's going to generate a positive value, and that's going to be an inflow. Okay, and we'll use this terminology throughout subsequent videos where we're solving problems here. Okay, so after I hit comma here, it asks me, do I want the interest to compound at the end of the period or the beginning of the period? And in most of the problems that we work, we always want the interest to compound at the end of the period. So I'm going to type in 0 there and close my parentheses. Okay, so this is equal to the future value of this $5,000 payment 65 years from now, earning 12.5%. I hit enter and I get 10,565,351.82. If I scroll all the way down, that number should be the same as that, 565,352. Okay, there was a slight rounding there. So that is the formula to solve for the present value, or I'm sorry, the future value of this $5,000 investment. Let me show you one other tool that I'll use periodically. What I'm going to do is I'm going to use a financial calculator. Okay, and the financial calculator is going to act a lot like Excel. Let me make this a little bit larger. The financial calculator is going to act a lot like Excel. This is the Texas Instruments BA2 Plus, and these 5 buttons here are going to be my time value of money functions, and they act just like Excel. Okay, so what I'm going to do, let me first format this calculator a little bit. This will be important. This second button acts as a shift key. So if I hit that, and then I hit the decimal button here. Above that, it says format. This allows me to format my calculator and make sure that I have more than 2 decimals. I want more than 2 decimals just because I want to be able to see it, and I want to make sure that I don't have any rounding error. So after I type in 4, I hit the word or hit enter here, and that increases my decimals to 4. Okay. And now to solve for the problem, just like I did in Excel, I'm going to say $5,000, and I'm going to put a negative sign in front of that and enter it into the present value function. Again, the calculator and Excel are using this different form of arithmetic in order to solve. They use this solver system, which requires a negative number to be put in. The $5,000 was an outflow from your parents' pocket. Therefore, I'm going to say negative 5,000, enter that into my present value. Again, there's no reoccurring payment, so I'm going to say 0 payment. My I over Y is 12.5%, and in this particular calculator, I actually use percent instead of decimal. So I'm going to say 12.5 and enter that into the I over Y. That's my rate of return per year, or my interest per year. That's what I over Y stands for. Okay. And N is going to reflect the number of compounding periods, or it's going to be T according to the formula that we've been using. So I'm going to say 65, enter that into the N function. Okay, so I've entered in negative 5,000, 12.5% I over Y for 65 years. To compute future value, I hit the CPT button. This is compute future value. And I get 10,565, 352, which is the same as what I got by hand in Excel, which is the same using the future value function Excel, and is now the same using this financial calculator. So that's it for this video. What we're going to do next is we're going to introduce a whole bunch of new problems. I'll probably answer a bunch of those problems in one small video, maybe 3 or 4 of those problems in one small video. And this will get us used to using the financial calculator in Excel and solving time value of money problems.